Howdy folks, Mr. Holdeman here. Today we're going to talk about solutions, and we're going to make our own because oftentimes in chemistry you need a very specific concentration of solution to do in chemistry lab. So we're going to make our own in two different ways. First is with a solute and a solvent, and then second we're going to dilute that solution to get an exact concentration of what we need. Now some of these concentrations can be dangerous, so it's important to have your lab equipment. Actually, you know what? We can demonstrate this just using Kool-Aid, so let's do that instead. If you're following along, some things you might need: writing utensil, calculator, paper, and then to do the lab, all we need is our solvent, a solute, something to mix them in, something to stir it with, and something to measure each with. Now what I've got here is kind of like a graduated cylinder, a kitchen measuring cup that has milliliters on the side. So if we measure the cup next to it, we see that these cups are about 80 milliliters. So that's what we'll use for a volume of our solvent. Now for our solute, we're going to have to calculate it. So let's look at one example of how to measure exactly how much we need. Who thought making Kool-Aid be so complicated? So the first thing we're going to do is to create a 0.2 molar solution. So if you're following along on the document, this is the first example, and we want to figure out how much powder we need to put in each one. So we're going to use the molarity equation, and we know that molarity is equal to the moles of solute over the liters of solution. And this is the total solution, and this is the solute, so this will be the powder that we put in. So we have our molarity. We know it needs to be 0.2 molar. And we don't know how many moles we need of that solute, but we do know the liters of solution. So in the bottom here, we know the volume of each of those cups. And we said this was 80 milliliters. So we need to convert milliliters into liters to plug it into this equation. 1, 2, 3. Move that decimal 3 spots over, we get 0.08 liters of solution. So that's roughly how much water we should put in. So if we calculate this, we're going to multiply 0.08 times 0.2, and we get 0.016 moles of Kool-Aid. Now, I don't have a scale that can measure moles of Kool-Aid, so we need to convert this into grams. Now, we can assume that our 0.016 moles of Kool-Aid is 100% sucrose. So we're going to convert that into grams of sucrose. What do we have to do? You got it. Train tracks. Here we go, 0.016. Start with what we're given. Let's write it as a fraction over 1. And what we need here is the molar mass of this. So we've got 1 mole of sucrose. And we know that that's going to be equal to 342.3 grams of sucrose. So when you calculate this out, you get 5.48 grams sucrose, which for our scale, I can only measure it to this first, the ones place. So we're gonna say that is 0.5 grams. So for the first one, we're going to turn on our scale. And we want to measure this in grams, because that's what our calculation told us. And then when we put the cup on, we want to tare the scale, or zero it out. So we calculated that we needed 5 grams. So I've got my scoop. I'm going to slowly add till we've got 5 grams. The important thing is that you put the solute in before you put the solvent. So after that, we can take it off the scale, because that's all we needed, and we're going to fill this up to the top of that cup. That's about 80 milliliters at the top. Don't overflow. And then stir, stir, stir until all of that solute is dissolved. For some of these concentrations, this might take a little bit of while. For some of these concentrations, this might take a little while. And there we go. We've made Kool-Aid. Delicious. So this is 5 grams to make a 0.2 molar solution. You need to repeat this calculation 2 more times for 0.5 molar and 0.8 molar solutions. So we want to find out how many grams we can add to that to get those 2 concentrations. That will be your work to do, and you'll have 2 quiz questions on exactly that process. The second way that we can come up with an exact concentration of solution is by diluting it. So the equation for this is M1V1 equals M2V2. Now M is your molarity, V is your volume. So we have the initial molarity times the initial volume equals the diluted molarity times the diluted volume. We call this the stock solution. And the second one is called the diluted solution. So if you remember from the PhET simulation, this would be like adding more water. We're just diluting it. So whenever we take a look at a new equation, it's a good idea to look at the units. So we've got the units for molarity, which is moles per liter. Let me label that we're looking at units here. So the units moles per liter, we're going to multiply that by the unit for volume, which is liters. And when we do that, liters cancel out. So what we're left with is moles. So we're actually comparing moles on this side to the same exact thing on the other side. So this tells us that the moles stay the same, even though we have 2 other things on there. Those cancel. So moles side 1 are equal to the moles on side 2. That's the one thing that stays the same with the diluted solution. So even though we change the volume from before and after, we also change the molarity before and after. The one thing that stays the same is the moles. Let's take a look at an example. Pretend that we made 0.8 molar solution, but that was just way too sweet. So we want to dilute that. So let's say 0.8 molars diluted to whatever that lowest concentration was, 0.2 molars. Maybe you really like this one. So let's see what we looked at for this one. So our equation again, M1V1 equals M2V2. So our before solution, we knew that it was a molarity of 0.8 molar. And our cups had they had 80 milliliters, so we said that was 0.08 liters. So those are our 2 units that we need for this equation to work. And that's going to be equal to molarity times the volume afterward. And so that's going to be that one. So we'll start out 0.2 molar is what the concentration was afterward, and we want to find out what volume we would need to add to this. What is our final volume when we dilute this solution? So pretty easy. We need to divide 0.2 to both sides. And we come out that after we dilute it, the total volume for V2 is going to be 0.32 liters, or 320 milliliters, which makes sense. We started with 80 milliliters and we had to add enough so that we ended up with 320 milliliters of our diluted solution.
Little post-edit clarification here. If we started with 80 milliliters of our stock solution, we would have to add 240 milliliters of our solvent to that for a total volume of 320 milliliters. Remember that the number of moles is the same and the total volume is reflected in what we just calculated.
Okay, now another example we can do in the real world. This is the 0.8 molar solution and it's filled to the top. I've got 80 milliliters of it, but this is just too sweet for me. The more concentrated something is, the sweeter it tastes. So I need to dilute this down. So I'm gonna pour out a precisely measured 20 milliliters into this cup. Now, this is not a trick question. What is the molarity of the solution in this cup? This isn't even a dilution problem. It is still 0.8 molar. All we did was pour it into another cup. Don't let that confuse you. So what we're gonna do is dilute this from 0.8 molar. We're gonna pour water into it until we get up to 80 milliliters. So this is dilution in action, folks. Pure water, add that until we get to 80 milliliters. You might notice the color changed a little bit. It's not as purple as the original solution. We want to find out what the molarity of this new solution is. So now we can do our calculation. So we've got M1 V1 equals M2 V2, 0.8 molar. Remember again that we have to convert these into liters. So we're going to do 0.02 liters. Now our diluted solution. We want to find out the molarity, and we know that we diluted it up to 0.8 liters. Divide both sides by 0.08 liters. And we get back to our original 0.02 molar solution. So if we started out with a more concentrated solution, but we wanted a less concentrated solution, this is how we can figure out what molarity we would need and how much volume to add. So, another bonus opportunity for you. If you choose to do this lab, you can make Kool-Aid, lemonade, iced tea, whatever you want, but you have to make 3 different concentrations and show evidence that you calculated exactly how much solute and solvent go in each one. And tell your teacher which one you like best. Evidence could be a picture, calculations. Send it in the email to me if I'm your teacher, or Mr. Lackey if he's your teacher. Have fun, go Cats.
Hey folks, a little extra bonus here. This isn't an opportunity, just a post-editing interjection from Mr. Holderman. I think about this stuff all the time. So even if it's not making Kool-Aid, this is a pretty real-world, hands-on example. But this is a pretty good thing to use in a lot of different cases. So for example, I'm working on the plumbing on my house right now, and yesterday I watched a video about a bathroom fan. And you want to use a bathroom fan when you take a shower, so it clears out the moisture and you don't grow mold in your bathroom. And they are rated in cubic feet per minute. So how many cubic feet of your bathroom can it get out of there? Because obviously the moisture is in there, and that's the stuff that you want to get out. So when it sucks the air out, it's sucking that moisture out, but also you're gaining new air in. So what happens is that air mixes with the moist air that's already in there, and it dilutes it. So it'd be nice if we could get rid of all the moisture all at once and then bring in new air, but it doesn't quite work like that because we're doing a dilution. Also, plumbing issue. If you have a leaky toilet and sometimes you put in blue drops in the back of the toilet, and then you see if they filter down into or sink down into the toilet bowl. That's another dilution. You can watch that dilution happen because it turns the water blue, but then as it slowly leaks new water, maybe it leaks over a couple of days, slowly leaks new water into it, it dilutes it back up to normal color. So, just a couple of things that I think about on a daily basis. And the more chemistry you know, the more places you can use the idea. So, the end. That's all. Cool cats.